Yes, welcome back. In previous class, we have seen the transmission gate operation or the regions of operation of MOS transistors of transmission gate while transmitting a transition 0 to 1 under large capacitive load. Now, under the same case, that is a large capacitive load, let us see the operating regions of NMOS and PMOS transistors of transmission gate while transmitting a transition 1 to 0. Okay, so here what happens is the input voltage is comes to 0 very fastly, but output may not come to 0 very fastly, okay, because the capacitance is very large. So a falling ramp you can see at the output, right? Now see the operating regions of NMOS and PMOS transistors with reference to output voltage. Suppose if the output voltage is less than VTN, see this is the waveform representation. If the output voltage is less than VTN, both the NMOS transistors and PMOS transistors are in saturation region. Both transistors are in saturation region. That is, comparing the difference between input and output voltages, you can say that the NMOS and PMOS transistors are in saturation. Okay. Suppose if the voltage is in between VTN and VDD minus VTP, the NMOS transistor now comes to linear region, whereas PMOS transistor operate in saturation region. Okay. Suppose if the output voltage is greater than VDD minus VTP, the NMOS transistor operate same in the linear region, but PMOS transistor comes to cutoff. Okay, so that the corresponding currents of PMOS transistor and current of NMOS transistor falling is like this. Okay, so here this is the point where the PMOS transistor goes to cutoff. PMOS transistor goes to cutoff. That's why its current IDSP current becomes 0. Okay, and similarly the corresponding resistance value is the resistance of PMOS transistor comes to infinity whenever the current is 0. Okay, similarly let's take the case of low capacitive load. Okay, small capacitive load. If the capacitance is very low, the output voltage always almost equal to the input voltage. That is, the voltage difference between input and output is very less. Okay, the voltage difference between input and output of the transmission gate is always very less. So that these two diagrams B and C represents the currents of NMOS and PMOS transistors and corresponding resistances. Okay, let us take the cases like, suppose if the output value is less than VTP, that is coming to first diagram. This is the diagram. Observe here, if the output is less than VTP, what happens is the NMOS transistor operate in linear region, whereas PMOS transistor in cutoff. Okay, so that since PMOS transistor is cut off means IDSP current is 0. Here IDSP current is 0. Okay, whereas IDSN current and NMOS transistor current is very high. Okay, after that with the incremental of output voltage, when the output voltage is greater than VTP but less than VDD minus VTN, both are in the linear region. Both the transistors are in linear region. And suppose if the output voltage is greater than VDD minus VTN, the NMOS transistor goes to cutoff, whereas PMOS transistor in the linear region. Okay, so that's why with output is greater than VDD minus VTN, the NMOS transistor comes to cutoff. Therefore, its current becomes 0. This is the IDSN current. It slowly comes to 0, whereas the PMOS transistor current is slowly increased to maximum value like this. And the equivalent current with reference to transmission gate is like this. With reference to these currents, the resistance values of PMOS transistor and NMOS transistor variation is represented in this second diagram, that is C. This is the curve of resistance of PMOS transistor NMOS transistor, whereas this is the variation of resistance with reference to PMOS transistor, and this is the total equivalent resistance value. Okay, so these things you have to remember with reference to transmission gates. Okay, thank you.